Before we start this next chapter, which is 3 and 12, I want to talk about a few things. Remember back in chapter 1, we learned that x bar, which is a sample mean, is the estimated value of mu, the population mean. And in chapter 7 and 8, we learned that p hat, which is a sample proportion, is an estimate of p, which is a population proportion. But we are kind of in the same boat here. Well, we used y hat as a prediction of mu of y. So this y hat equals a plus bx is actually our sample line, the points that we have in our hand, and mu of y is equal to alpha plus beta x. That's the true line. Now, I'm going to back up one more time to Algebra 1. You learned that y equals mx plus b, with m being the slope and y being the b being the y-intercept. But what did you do when you graphed the line? Well, you started with b, and then you went up and down and over based on your rate of change, which is m. So since we did that, we just decided to put the a first, which is the term that we use for y-intercept, and put the b, which is the term we use for slope, second. So now we have y hat equals a plus bx, and that's what's used to predict mu of y equals alpha plus beta x. Now, the y hat is a predicted value of the y, and we really emphasize the word predicted value. A is the y-intercept. It's an estimate of alpha, which is the true intercept of the line, and b, which is the estimate for beta, which is the rate of change, the average change in y for every 1 unit of change in x, and that's kind of our definition there. We have a couple other definitions that we use in statistics. Now, you probably talked about correlation in algebra. Correlation is simply the strength and direction of a linear relationship between two quantitative variables. The key points here are linear and quantitative variables. And we probably did not talk much about the coefficient of determination, but we will do in statistics. The coefficient of determination, which is r squared, so obviously they're related, is the percent change in y that is accounted for by the least squares regression line of y on x. So what that really means in plain English, but we can't say it this way on a test, is what percent of y is the change in y is a result of the change in x. So we have to use a lawyer talk, but we really want to think about it is the amount change in y that is because of the change in x.